Now let us understand the second condition. The second condition is when Vs is greater than Vz. I will take one example so that you can understand. See, here the Vs value which is there, as I said, we have taken the transformer of secondary voltage 12 volt, right? So the Vm value, maximum voltage across secondary, will be 12 volt, and whatever be the fluctuation will be around 12 volt. Okay, so say this is 12 volt standard. If it increases, it goes to 12.5, and if it is decreases, it will go to 11.5. So the total voltage, the fluctuation which is there, is between 11.5 to 12.5. And now what we will do is we will take a Zener voltage of Vz value equals to 9 volt, right? Now what we have understood is once the breakdown occurs, the voltage across Zener diode will be constant. Only the current through the Zener diode will increase. Okay, so if you apply 12 volt here, what happens? 12 volt is greater than 9 volt. That means Vs is greater than Vz. When Vs is greater than Vz, Zener diode goes into breakdown region. And if Zener diode goes into breakdown region, only the current through the Zener diode will increase. Voltage drop across Zener will remain at 9 volt. So the output voltage, and as Zener is connected in parallel to the load resistance, as these two are connected in parallel, what happens is the voltage drop across Zener diode will be the voltage drop across output. So we say V0 is equal to Vz. And what is Vz? Vz is equal to 9 volt. Suppose there is a fluctuation and the input changes to say 11.5 volt. Still 11.5 volt is greater than 9 volt. Zener diode is still in breakdown region. The voltage drop across Zener diode will be 9 volt. Therefore the output voltage will be 9 volt. If the output increases say 12.5 volt, what happens? Still 12.5 volt means still the Zener diode is in breakdown region. The voltage drop across Zener diode will be 9 volt, and therefore the output voltage will be 9 volt. So now when you draw a graph between time and voltage across output, what you are going to get is a straight line, right? You are going to get as a the curve as a straight line. That means the output voltage will be constant irrespective of any change in the input voltage, and that is how Zener diode can be used as voltage regulator. So when Vs is greater than Vz, Zener diode goes into breakdown region. Zener diode goes into breakdown region. That means voltage across Zener remains constant, current through the Zener diode will increase. So from that we get the formula as I is equal to Iz plus IL, and voltage drop across Zener will be constant. As voltage drop, as Zener and load resistance are connected in parallel, voltage drop across Zener diode will be the voltage drop across the output. So Vz is equal to, or we say V0, that is output voltage, is equal to Vz. Okay, there is very important condition of Rs. I told you I will explain the meaning of Rs, why Rs is there. Suppose you are applying 12 volt at the input. How much you are going to get at the output? You are going to get output as 9 volt. So you are applying 12 volt, you are getting 9 volt at the output. So what happens to these 3 volts? The 3 additional volt will be dropped across Rs. So can you derive a formula for voltage drop across Rs? I will call it as VRS, voltage drop across Rs. So what will be the formula for voltage drop across Rs? Total voltage minus the output voltage, right? The input voltage minus Vs, that is source voltage, minus the output voltage. As output voltage, as the Zener diode is in breakdown region, V0 is equal to Vz. So Vs minus Vz, both can be written. So the voltage drop across Rs will be given by that formula, Vs minus V0 or Vs minus Vz. Okay, now the value of Rs resistance is voltage divided by current, right? And what is the voltage drop across RS? Just now we have derived that formula, Vs minus V0, Vs minus V0. And what is the current which is flowing through RS? That is total current I. So we can calculate the value of RS by the formula Vs minus V0 upon I. And the same equation can be written as Vs minus V0 upon Iz plus IL. Okay, Iz plus IL, because I is equal to Iz plus IL. Both the formulas can be used. Okay, and last one, the output voltage, which if you can directly calculate, the output voltage is taken across load resistance, and current flowing through the load resistance is IL. So output voltage is IL multiplied by RL. Output voltage is IL multiplied by RL. Okay, so these are the formulas based on which there will be numerical asked on Zener diode as voltage regulator. I hope you have understood. The question for Zener diode as voltage regulator will be asked for 4 marks. Of course, we have to draw the diagram. We have to specify 2 conditions: Vs less than Vz, Vs greater than Vz, which we have already done. We have to explain 2 more terms. The first one, which is called as line regulation. Okay, line regulation. Please try to understand this thing. Line regulation is the change in the output voltage due to change in the input voltage when RL, that is load resistance, is constant. When RL is constant, that means change in the output voltage due to change in the input voltage when load resistance is constant. But what we are designing? We are designing a voltage regulator. That means the output voltage should remain constant. It should not change with respect to anything, either the input voltage or the load resistance. Let us try to understand how this thing happens. Okay, suppose, see what happens is, suppose initially it is 12 volt, and here of course as the Zener we have selected as 9 volt, the voltage drop will be 9 volt. Suppose suddenly the voltage has increased to 15 volt. Okay, first we have applied 12 volt, the output voltage is 9 volt, the voltage drop across RS will be 3 volt. Now suddenly the input has increased. There is a sudden change in the input from 12 volt to 15 volt. What happens is, still the Zener diode is in breakdown region because Vs is greater than Vz. And if that is true, the voltage drop across Zener will remain constant. That means the output voltage will be still 9 volt. But what will happen to the voltage drop across RS? The voltage drop across RS will now be 6 volts instead of 3 volt, right? So if I see this formula as I is equal to Vs minus V0 upon RS. RS is constant. Vs minus V0 first was 3 volt, and then when the input was increased, the Vs minus V0 has become 6 volt. That means I will increase. And if I increases, Iz and IL both increases. And if Iz and IL increases, if IL increases, we said RL is constant. If IL increases, output voltage will increase. But we have designed a voltage regulator, the output voltage should remain constant. Now let us try to understand. See, what happens is, when the input voltage is increased, as I said, Zener diode, the voltage across Zener diode will be constant, but the current through the Zener diode increases. This is because the resistance offered by the Zener diode will decrease. Okay, so now there are 2 paths for current to flow. RL is constant, that means resistance in this path is constant, and when you are increasing the reverse voltage, the resistance offered by the Zener diode will decrease, and current always has a tendency to take least resistance path. That means of course current I will increase, this current will come up to this point, but what will happen is between these two paths RL is constant, the resistance in this path is constant, and the resistance in this path is decreased. So all the excess current will decrease, or all the excess current will flow through the Zener diode. That means when I increases, IZ increases, but IL doesn't increase. And if IL is not increased, output voltage will remain constant. So output voltage remains constant irrespective of any change in the input voltage. Of course, that is called as line regulation. The next term is second one, load regulation. Load regulation. It is the change in the output voltage, when output load resistance changes. Output load resistance means RL changes when input voltage is constant. Okay, so it is the change in the output voltage due to change in the output load resistance when the input voltage is constant. Okay, so now when the input voltage is constant, see, when the input voltage is constant, I is constant, right? Because if the input voltage is at 12 volt, output is at 9 volt, the output voltage, the voltage drop across RS will be 3 volt. So I remains constant, and if I is constant, IZ plus IL will be constant. And if IL is constant, RL tends to decrease. What happens is the output voltage will tend to decrease, but that should not happen because we have designed a voltage regulator. The output voltage should be constant. So what happens is, now see what happens. As I said, current I will remain constant. The current is distributed depending upon the resistance offered by these two paths. Now what happens is, as I is constant, right, the voltage drop, the Zener diode, the resistance offered by the Zener diode will be constant. That means resistance at this path will be constant. Now what we are trying to do is, we are decreasing RL. Okay, so the resistance in this path will decrease. So the excess current which was flowing through Zener will now flow through IL. That means I will remain constant, IZ will decrease, IL will increase. So when RL decreases, IL increases. To compensate that, of course, IL increases, and if that happens, the output voltage will be constant. So irrespective of any change in the input voltage or any change in the output load resistance, the output voltage remains constant. So this is how we will try to explain Zener diode as voltage regulator. I hope you have understood. Next, we will try to understand numerical based on Zener diode as voltage regulator. The first type is this. This question has been asked in board exams number of times, so make sure that you understand things properly. Okay, in a Zener diode as voltage regulator, we need to calculate output voltage, voltage drop across RS. Third is Zener current. This question has been asked for 4 marks for the following circuit. Okay, these are the formulas based on which we have to solve the problem for Zener diode as voltage regulator. So in this figure, what we can see is, first thing which we have to remember is, we have to see whether the Zener diode is connected in forward bias mode or not. Zener diode is connected in reverse bias mode or not. That means P should be connected to negative, N should be connected to positive. Yes, that is true. And second very important thing is, for Zener diode to be used as a voltage regulator, Vs should be equal to or greater than Vz. Vs is 50 and Vz here is 25 volts. So Vs is greater than Vz. So both the conditions are true. That means this circuit will work as voltage regulator. See how to write this thing. Okay? So the first thing we will write is, as Vs is greater than Vz, Zener diode is in breakdown region. And when Zener diode is in breakdown region, the voltage across Zener will be constant. As Zener is connected in parallel to the load resistance, voltage across Zener will be voltage across output. So V0 is equal to Vz. So V0 is equal to, what is Vz? Vz is 25 volt. So we got the first answer, output voltage. Next, what is voltage drop across Rs? When the voltage drop across Vz is 25 volt, the output voltage will be 25 volt. So what will be the excess voltage? Where this excess voltage will go and drop? Will drop across Rs. So what will be the formula for voltage drop across Rs? We specify it as Vrs. This will be the second one, Vrs. And what is Vrs? Vrs is total voltage, that means input voltage minus the output voltage. So Vs is 50 minus 25, that is 25 volt. This will be the voltage drop across series resistance. This is the second part. Third part is, the third one is Zener current. That means we are trying to calculate Iz. What is Iz? By this formula, I is equal to Iz plus IL. So what will be Iz? Iz will be I minus IL, right? I minus IL. So we, of course, we don't know both this thing I and IL. We need to calculate I as well as IL. So by this formula, what is I? See, I is Vs minus V0 upon Rs. What is Vs minus V0? We just calculated, that is 25 divided by what is Rs, that is 100. So this value will be 0.25 ampere as we are calculating current. Okay, so that is the value of I. And what is IL? IL by this formula, what is IL? IL is V0 upon RL. V0 is 25 divided by 500. So this value will be this value will be how much? This value will be 1 upon 40. Okay, 1 upon 40. That value will come out to be, or I will say 25, right? 5 by 100. Okay, so 5 by 100, this value will be 0.05 amperes. Okay, 0.05 amperes. So what will be Iz? It will be I minus IL. That means 0.25 minus 0.05, that is 0.20 amperes. That will be the value of Iz. Okay, so only the values will change, but the question will be asked exactly in the same manner. So this is one way of asking questions or asking numerical question on Zener diode as voltage regulator. I hope you have understood. Let us try to understand one more type of problem being asked on Zener diode as voltage regulator. Again, this question will be asked for 4 marks and very, very important. It says, in a Zener diode as voltage regulator, the input voltage varies from 80 volt to 120 volt. I just said the input voltage for Zener diode as voltage regulator will be from the filters, and the filters value will be fluctuating. Say it is moving or it is fluctuating from 80 volt to 120 volt. That means minimum value is 80 volt, maximum value is 120 volt with series resistance of 200 ohms and load resistance of 800 ohms. We need to calculate minimum and maximum Zener current, and it is given that Vz is equal to 40 volt. So let us first write everything. What is Vs minimum? That is source voltage. We have two values, Vs minimum and Vs maximum, which is 80 volt and 120 volt. Rs is equal to Rs, that means series resistance is 200 ohms. RL is equal to 800 ohms, VZ is 40 volt. These things are given and we are asked to calculate minimum and maximum Zener current. That means IZ minimum and IZ maximum. And what is Zener formula for Zener current? IZ is I minus IL. In this case it will be I minimum minus IL, and here it will be I maximum minus IL. So what we need to calculate is three things: I minimum, I maximum, IL. If you calculate these three, we can easily find out the value of IZ minimum and IZ maximum. So the first is I minimum, and I minimum by this formula, I here, RS here, I minimum will be Vs minimum minus V0 upon Rs. Now here V0 is not given, but in both the cases, even if the input voltage is 80 volt or input voltage is 120 volt, as Vz is 40, the Zener diode is in breakdown region, and as the Zener diode is in breakdown region, output voltage is equal to Zener voltage. That means output voltage will be equal to 40 volts. So if you substitute this value, what is Vs minimum? That is 80 minus 40 divided by what is the value of Rs? That is 200. So this is 40 upon 200, 1 upon 5, that is 0.20 amperes. This is I minimum. Next is I max. What is I max? Vs maximum minus V0 upon Rs. So Vs minus V0, Vs max is 120. 120 minus V0 of course will be 40, as Zener diode is connected in reverse bias mode and Zener diode is in breakdown region. V0 will be equal to Vz, so it will be 40 upon 200. So this value will be 80 by 200, which is 0.40 amperes. Okay, so that is Iz maximum. So we I maximum. So I minimum, I maximum we have calculated, and we need to calculate IL. IL by this formula, V0 upon RL. V0 is 40 upon, I will write here, V0 upon RL. And what is V0? V0 is 40. 40 divided by RL is 800. Okay, so this value will be 1 upon 20, and 1 upon 20 will be 0.05 amperes. Okay, so we have got all the three. So what will be Iz minimum? I minimum is 0.20 minus 0.05, which is 0.15 amperes. Similarly, Iz maximum will be I maximum, which is 0.40 minus 0.05, which will be 0.35 amperes. So this is your answer, and this will fetch you 4 marks. So these are different types of numericals based on Zener diode as voltage regulator. I hope you have understood.